Welcome to Pomodoro Joe for Wednesday, August 30th, 2023. Today we're looking at LeetCode problem 2366. Minimum replacements to sort the array. This is a hard problem. You are given a zero-indexed integer array, nums. In one operation, you can replace any element of the array with any two elements that sum to that element. For example, consider nums is equal to 5, 6, 7. In one operation, we can replace nums index 1 with 2 and 4 and convert nums to 5, 2, 4, 7. Return the minimum number of operations to make an array that is sorted in non-decreasing order. All right, let's look at this example here. So we have 3, 9, and 3. All right, now we know that we can't make our elements any larger. We can only make them smaller. So the largest element in our array can be 3. Because we can't make this any bigger, and that's the last element in our array. So our array has to have elements that are 3 or below. All right, so our 9, we can split that into a 4 and a 5, and then we can split each of those 4s and 5s into something that's smaller than 3. But that's going to take a couple different splits, because we'll have to split both the 4 and the 5. Or we could split the 9 into a 3 and a 6, and then we can split the 6 into a 3 and a 3. So that's 2 splits. So our answer is 2. All right, and then we have another example here, 1, 2, 3, 4, 5. It's already sorted, so we can just return 0. Okay, so let's put 25 minutes on the Pomodoro timer and we will get started. All right, so let's start with our result. We'll set it equal to 0 to start with. And we will return our result at the end. All right, now how do we do this one? So as I pointed out, if we look at our last element, that is going to be the largest it can possibly be. We can only make it smaller, and we don't really want to make it smaller because we want that to be the largest element in our array. So we already know that if we look at the last element, that sort of defines the largest element in our array. Now we could go from left to right, starting at index 0, going through, keeping track of what's the largest element we've seen so far. If we find something out of order, we can always split our element. But at that point, it's kind of too late. Like if we find something in the future that's smaller than something we split in the past, we're going to have to go back and resplit something. So going from left to right is probably not the best option. If we go from right to left, however, so that's going backwards in our array, then when we find something that's larger, we can keep track of the smallest element we've seen so far. Now, the smallest element we've seen so far going backwards means everything before that element has to be smaller than it. So if we move backwards, or from right to left, we can keep track of the smallest element we've seen so far. That defines our maximum element, and then we can make sure that any element that comes before that, we split into smaller elements. Now, how we split it is another question, but we'll get to that in a minute. So let's just start by going backwards through our array, keeping track of our current maximum or current minimum value. And then we'll see if we find new values that we have to split. Maybe we'll make a helper function to split those values. Let's do this. All right, so for this, I do need to keep track of this minimum element we've seen so far, or maybe I'll call it the target, or what do I call it? All right, I'm just gonna call it min number. Okay, so the min number is our current maximum that we're trying to get below. Min number seems like a bad name for it. Maybe I'll just call it target. I'll just do that. We'll call it target. All right, so our target value, this is the number that we have to get below, or we can actually be equal to the target. We just can't be above the target. Okay, so at this point, our target is going to be nums at the end, so that's -1. So in the beginning, our target is the very last number in our array, so that's nums index -1. All right, now we have to go through all of the other elements in the array. So for every index in range, let's see, we'll go from, I need the length of my numbers here. So number count, that's the length of the nums. All right, and remember, we're going from right to left. So we're going to start at the end. So that's going to be our nums count -1. Start at the very end, but we're already using that as our target, so let's do -2. All right, And then we'll go all the way down to 0, which means we have to overshoot by 1. So we have to go down to -1, and we'll go by steps of -1. So this will take us from right to left. All right, so now our current number is just nums at index I. And basically we want to check to see if this is less than our target, then we don't need to do anything with this number. We don't need to split this number, but we do need to update our target because our target then becomes this new number. So I guess we can do that here. I should say less than or equal to. All right, so if this number is less than or equal to our current target value, then this number becomes our new target. So this number does not need to be split. It's already less than our current target. But that means that everything that comes before this number has to be less than or equal to this number. So in this case, our target becomes this num, and then we'll just continue. All right, now if this number is greater than our target, that means we need to split this number. So for this, I'm actually going to use a helper function. So let's see, let's do a split num, and we'll pass in the number, and we'll pass in the target. So now we need to split this number into something that's the best option for getting it below this target value. Okay, and what do we get out of this? Well, let's see. Well, we'll need to get the new number out of this. So we'll have some new num, and that's going to equal this split num, passing in the nums in the target. And then that new num is actually our new target. So actually we can just set this to our target here. Okay, so let's create our helper function. Okay, so for now I'm just going to pass. Okay, so we're going through our array. We're going from right to left. We're checking to see if our number is less than our current target. If it is, we just move on. If it's not, then we have to split this number. So for that, I have a helper function, split the number. Now it will return the new target, but we also need to know how many operations this took. Like if we just split the number once, maybe it's no big deal, but we might need to split the number 2, 3, 4, who knows how many times. So in that case, I need to return not just the new target, I also have to return the number of operations performed. So in that case, I'm going to have to make a note here. My return value, that's going to be the op count and the new target. Or you could do it the other way around, new target, then op count. In fact, I'm going to create some helper variables out here so I don't lose track of what is what. So the op count will be 0, and the new target will be 1. These are indexes, or indices. All right, so now instead of just passing back the target, we'll pass back the target and, actually I got this the other way around, so I got the op count and the target. And now our op count will get added to our result. So this is how many operations we had to perform in order to split this number into our new target. So let's see our result. That's going to increase by this operation count. Okay, so this is looking pretty good. Now we just have to do the hard part, the split num part. All right, so how do we split our number? Well, let's see. I guess one thing I'd like to do is keep this new target as great as possible. We'd like to have this new target be as close to our current target as possible. Otherwise, it's going to have to be below our current target, which means that anything that comes before that has a lower threshold. So we'd like to keep our new target as close to our current target as possible. So one thing we could do is split this number into two elements, one that is the target itself, and the other is this number minus the target. So whatever's left after we split out two elements into the target and something else. So we could keep going through that. We could split this into a target and something else. Then we can split that something else into a target and another smaller something else and keep splitting it by target. All right, in the end though, we'll end up with some remainder. So this is basically, we're just dividing our number by the target. That tells us how many times target will go into our number, and then we'll have some leftover piece. Now, if we just use that leftover piece, that could be our new value, but that might be very small. So let's say we had number is 101 and our target is 10. So 10 goes into 101 10 times with a remainder of 1. So we can split our number into 10 tens and then 1 1. Oh, but that means that 1 1 becomes our new target, and that's a very low bar. That means all of our other values that come before this number have to be at max value 1. Now we'd like to keep that a little bit higher, so we could spread out that additional 1, or how do I put this? So instead of splitting it into 10 tens and a 1, we can try to spread the difference out among those 10 tens. So we could have 9 tens and then split that remaining, what would that be, 11 out into 2 elements. So we could have 9 tens and then a 5 and a 6, or we could have 10 nines. So ideally we just want to keep this target as large as possible. So let's have some helper variables here. So our op count, we'll set that equal to 0, and our new target, we'll set that equal to our target, because hopefully that's our ideal target right there. Okay, now one thing we could do, if our number here is evenly divisible by our target, then we'll just split it by that target, and then we can return our op count and our new target. That's a pretty simple one. All right, so if our num modulo target is equal to 0, that means our number is evenly divisible by the target, then we can just divide our number by that target. That becomes the number of operations we perform, and it becomes our new target. So let's see here. So our operation count will be just this number divided by this target. Let's see, how does that work? If the number is 20 and our target is 10, we'll do one split to divide that into 2 tens. So that actually gives us our num divided by target minus 1. All right. So the number of operations we perform will be the number divided by the target minus 1 in this particular case. All right. And then our new target, well, that doesn't change. It's still our target. And then we can return. So in this case, we'll return our op count and our target, our new target. All right, now if this is not evenly divisible, then what's the best way to spread out this difference that we need to make up? So I think I'll actually make this an else statement here. I'm just going to pass for now, and then we'll return our op count and our target outside. Okay, so now we are actually at the hardest piece. How do we divide this up into the minimal number of operations while keeping our target maximized? Well, we can kind of take a clue from this. So if we just knew how many of our current target can fit into our current number, that tells us how many elements we're going to split our current number into. So if we had, again, 20 and 10, so if 20 is our number and 10 is our target, we're going to split our number into 2 elements of 10. If our number is 100 and 10 is our target, we'll split our number, 100, into 10 new elements of 10. So if we know how many elements we're going to split our number into, then we can spread out our current number among all those elements to get our maximum value or our maximum target. So let's do that. So I'll call this the element count. So this will be our number divided by our target. So that's how many of this target will fit into our number. So that's how many new elements we'll have to create out of this number. Now we will have to add 1 to that. For example, if we had 21 as our number and 10 as our target, well, when we do the division, it's going to round that down to 2. But we need 3 new elements because we have to fit 21 into 3 new elements. We need at least 3 elements to fit 21 in there while each element stays below our target. So we have to do our number divided by our target, and then we have to add 1 extra element. So now that we know how many elements we have to divide our number into, Now we can maximize the value of those elements by just doing the division of our current number divided by the number of elements. So our new target will just be this number divided by the element count. And we still need to calculate our operation count. So that's just going to be the number of elements that we're going to create. So that's our element count minus 1. So this is basically, you can think of it as the splits are the divisions between numbers. So the number of elements that we have that number of elements minus 1 divisions between numbers. So if I've got 2 elements that I've created out of my 1 element, if I had 1 element and I split it into 2, that was 1 operation. So 2 elements means 1 operation. 3 elements means 2 operations, so on and so forth. All right, so I think this might do it. Man, this is a tricky one. Okay, so we're just going to go through from right to left, keeping track of the largest value we've seen so far. Or I shouldn't say largest value, the smallest value. So we're just going to go through our array from right to left, keeping track of our maximum target or the minimum value we've seen so far. So all of our values that come before this target value must be smaller than or equal to our target. So if we find something that's smaller than or equal to a target, we're fine, we just move on. If we find something larger than our target, then we have to split that number into something smaller. So we have our helper function here that will split our number, giving us the minimum number of operations possible while keeping the target as large as possible. And to do that, we basically have 2 options. If we can divide this number evenly by our target, then we'll just divide it into that many elements and we're done. If we can't divide it evenly by our target, then we'll just divide it into as many elements as we need to. So that's just the number divided by target. So how many times target will fit in this number, plus 1 extra element, because we do need to round up here. Then we'll take that number of elements and divide our number by that number of elements to figure out what's the average or the best element value that we can use. That becomes our new target. All right, let's just run this and see how it goes. And it looks like it works. Let's see if we can pass all the tests. And we pass. And we do pretty well, actually. We beat 62% for runtime and 73% for memory, so that is not too bad. Now, I know this took a lot of time, so I don't have a ton of time to go over and make this any faster, but we could definitely make this faster. One thing is, I think some of this code is redundant. Like, I don't think we actually need to have separate cases for a modulo and the divide. I think we can wrap that into one case. And we also don't need to make this a separate function. It was just easier to lay it out that way, but we could embed this entire thing inside of our loop here. That might save us a little bit of time as well. Okay, well, this one is definitely a tricky one. I would recommend you try it out, try it on your own, practice this one, take a look at what other people do. If you do pass, let's see. Yeah, if you do pass, you can just jump in here and see what other people are doing. Top one here, super compact, look at that. Wow, that's fantastic. Anyway, I don't have time to go through it, but check it out. All right, I hope you enjoyed this, hope you had fun, I hope you learned something, I hope you can go out and write better code.